In the previous video, we have discussed acceleration and we have solved some numericals regarding that. Now in this video, we are going to talk about uniform acceleration. So what is uniform acceleration? First, we'll understand what is uniform acceleration. Let's say you have started a trip at a point A morning 6 o'clock. At what time you have started the trip? Morning 6 o'clock. Okay. At this point, your speed is 30 kilometer per hour. Okay. After reaching point B, at that point of time, the time is 7. Okay? At 7 o'clock, you reached point B. What is the time interval? 1 hour. At point B, okay, your vehicle speed is 60 kilometer per hour. Whereas I'll take this is 20 kilometer per hour. This is 40 kilometer per hour. Okay. You reached point C at 8 a.m. That means what is the time interval again? 1 hour. At point C, your vehicle speed is 60 kilometer per hour. Okay. Now we are going to understand uniform acceleration with this example. First we are going to understand, let us do this is also. At 9 a.m. you reach point D. At point D your car speed is 80 kilometer per hour. What is the duration here also? Time interval 1 hour. So now we are going to understand what is a uniform acceleration. So now we are going to calculate the acceleration between A and B. What is acceleration? Rate of change of velocity is called acceleration. Okay. So what is the initial velocity? 20. What is the final velocity? 40. Change in velocity. Velocity is changed. Right. So final velocity minus initial velocity by time. That is called acceleration. Generally, what is acceleration formula? Acceleration is equal to final velocity minus initial velocity by time. Here, what is the final velocity? 40 kilometer per hour. Minus what is the initial velocity? 20 kilometer per hour by time. What is the time? Time is equal to 1 hour. Then 40 minus 20, 20 kilometer per hour is equal to 20 kilometer per hour square. 40 minus 20, 20 by 1 is 20. Kilometer per hour by hour, kilometer per hour square. This is the acceleration of your car between AB. Okay. Next we are going to find the acceleration of your car between BC. Acceleration car between BC. When we talk about B and C, at B what is the speed of the car? 40. At C what is the speed of the car? 60. Then this will be the final velocity and this will be the initial velocity during this case. So final velocity minus initial velocity by time gives acceleration. If you want to find the acceleration between B and C, final velocity minus initial velocity by time we have to. That means 60 kilometer per hour minus 40 kilometer per hour by what is the time interval? 1 hour. Right? 60 minus 40. 20 kilometer per hour kilometer per hour square. 60 minus 40 for 20 by 1 is 20 only. These units become this. Kilometer per hour square is a practical unit of acceleration. Now we are going to find the acceleration between C and D. So acceleration between CD. How to find acceleration? Final velocity minus initial velocity by time. Here what is the final? C, when we talk about C and D, C will become initial, D will become final. What is the final velocity? 80. Initial velocity is 60. 80 minus 60 by time 1 hour. So 80 kilometer per hour minus 60 kilometer per hour by time is 1 hour. Then 80 minus 60, 20. 20 by 1, 20 kilometer per hour, kilometer per hour square. Okay. So here you just tell me what is the acceleration of the car between AB? 20 kilometer per hour square. Between BC also 20 kilometer per hour square. Between CD also 20 kilometer per hour square. Acceleration is same. Between A and B what is the acceleration is there. Between B and C also same acceleration. Between C and D also it is moving with the same acceleration. That means this car is moving with the uniform acceleration, same acceleration, constant acceleration. Why it is called constant acceleration? Because velocity is changing, but acceleration is constant. How? Here, velocity is changing equally in equal intervals of time. Acceleration is equal to what, Nana? What is meant by acceleration? Change in velocity. Change in velocity by time. So equal velocity, the velocity of the object changing equally in equal intervals of time, then that is called a uniform acceleration. See, so how much velocity increased? 20. Next how much increased? 20. Next how much increased? 20. Every time how much velocity increasing? 20. So 20 kilometer per hour increased in the first 1 hour, 20 kilometer per hour increased in the next 1 hour, 20 kilometer per hour increased in the last 1 hour. So equal velocity changes take place in equal intervals of time, then it is called uniform acceleration. So what is the definition of the uniform acceleration? If an object changes its velocity equally in equal intervals of time, then it is said to be moving with uniform acceleration. It is said to be moving with uniform acceleration. This is the uniform acceleration definition. Acceleration is same because every time same speed changes, same velocity changes in same intervals of time. 20 to 40, how much change? 20. 40 to how much time taken? 1 hour. 40 to 60, how much change? 20. How much time taken? 1 hour. 60 to 80, how much change? 20. How much time is taken? 1 hour. Okay, I hope you understand. So please note down this uniform acceleration. Now we are going to talk about non-uniform acceleration. Previously we have discussed uniform acceleration. Now we are going to talk about non-uniform acceleration. Okay. So let's say at point A, the speed of the car at 20. At point B, the speed of the car is 30 km per hour. At point C, the speed of the car is 60 km per hour. Okay. At point D, the speed of the car is 75 km per hour. Okay. To reach from point A to the B, it has taken 1 hour. From B to the C, it has taken 1 hour. From C to the D, it has taken 1 hour. Now we are going to find the acceleration between A and B. This point is A, this point is B. Between this, what is the acceleration of the car? So how to find acceleration? Change in the velocity by time. Change in velocity by time. So what is the change in velocity? What is the final velocity? 30. Initial velocity 20. 30 minus 20 by time. So we have to write 30 km per hour minus 30 minus 20 by time. How much, Nana? 1 hour. Okay, 30 minus 20, 10. 10 by 1, 10. 10 km per hour. What is the change in the speed during AB? 10 km per hour. Now between B and C. At B, what is the speed? 30 km per hour. At C, what is the speed? 60. To find the acceleration from B to the C, we have to find final velocity minus initial velocity by time. 60 minus 30 by 1 hour. Okay. 60 km per hour. 60 minus 30 km per hour by 1 hour. 60 minus 30, 30 by 1, 30. 30 km per hour. Now we are going to find the acceleration between C and D. When we talk about C and D, this will become initial, this will become final. So the change in the velocity is final velocity minus initial velocity by time. So 75 minus 60 by 1 hour. Okay. Acceleration between C and D is 75 km minus 60 km per hour by time. How much? 1 hour. 75 minus 60, 15 km. 15 by 1, 15 km per hour square. Okay. I forgot to write the square in the previous case. Right. See, what is the acceleration between AB 10, BC 30, CD 15? Is it same acceleration or different acceleration? Acceleration is different, right? That is why it is called a non-uniform acceleration. How do we get a non-uniform acceleration? Time interval same. This car taking 1 hour from reach point A to the B, B to the C also 1 hour, C to the D also 1 hour. Every time car is taking same time. Time interval is same, but the change in the speed is not same. First only 10 kilometers change in the speed happen. What is the change in the speed between B and C? 30. Next to 15. So different changes in the speed happen in the same time interval. Okay. So if an object changes its velocity unequally in equal intervals of time, it is called a non-uniform acceleration. Non-uniform acceleration. Why it is called a non-uniform acceleration? Because velocity changes, but the change is not same, unequal. See, here velocity changes, here also velocity changes, but the change in velocity is here 10, the change in velocity here 30, the change in velocity is here 15. So unequal velocity changes in equal intervals of time. It is called a non-uniform acceleration. I hope you understand the main difference between the uniform acceleration and a non-uniform acceleration. Please note it down.